Welcome to the live section of A1 Tutor. Here again we meet for another class, physics class. Yesterday we had the conclusion part of our topic, which was fundamental quantity. And today we are commencing another topic, a new topic. Okay. Before we proceed, I want to be rest assured that everybody can hear me. If you can hear me, please drop an emoji or say, yes, I can hear you. You can type in the chat box that I can hear you. All right. If you can hear me, please kindly signify. And if you can also see the board, kindly signify. All right. Okay, we have a response. So as I was saying earlier, I said yesterday we had the conclusion part of our topic, fundamental quantities. And today we are moving to a new topic, which is motion. Motion. We are moving to a new topic, motion. So for the sake of those ones that were unable to meet up with yesterday class, I will refer us to the YouTube channel of A1 Tutor. Do well to check the previous videos of physics class and also for other subjects, biology, mathematics, and English. All right, so we are moving on with a new topic today, motion. Motion. Now, when you hear the word motion, what comes to your mind? What comes to your mind? Motion. When you hear the word motion, what comes to your mind? Now, I'm going to cite two illustrations now. Then you're going to give me which of them seems to be motion to you. Okay, so we have an object A, okay, an object A, or let me say, okay, we have a boy standing here. So let me use this to represent the boy, and this is a route, or let me say a straight line. Then we have another boy representing B standing also, okay? So for the first one, this boy remained on that spot for the past few minutes, right? Then for the second illustration, the boy labeled as B here moves from this point to this point, moves from this point to this point. And this boy here remains on his own position without taking any movement. It still remains on that same position. So looking at these two illustrations, we can see that we have two things. One was static, one was moving, right? We have one of them that was static and one of them was moving. So in between between this image, this illustration, and this illustration, which of them is at rest? Let me ask that way. Which of the illustration represents someone at rest or an object at rest? I want you to give me a reply in the chat box. You have illustration. The first illustration talks about the boy I labeled as A. Then the second one, the boy I labeled as B. The boy labeled as B moved from his initial position to another position. Okay, let's write initial here. then final position here, and this is inertia, no movement. Okay, so I'm asking the question that between the first and the second illustration, which one represents a body or an object at rest? Is it the boy label? Is it the illustration that talks about the boy labeled as A, or the illustration that talks about the boy labeled as B? So I want your response in the chat box. I'm waiting. If you have a response to that, I would like to have your response. I believe you can hear me right. So the question is, we have an illustration here. This A represents a boy standing and not moving, right? Then the second one here represents a boy. B represents a boy that moved from his initial point to a final point. Okay, from his initial point to a final point. So if this is point X and this is Y, and this is point X and this is Y. But the first boy labeled as A did not move an inch. But here, the boy moves from point X to point Y. So I'm asking the question, which of them is at rest? At rest. Which of them is at rest? And which one is in motion? Which of the boys is at rest? And which among the two boys is in motion? Okay, I'm waiting for a response in the chat box. Just type the alphabet. If it is A, you said A is at rest. And if it is B, you said B is at rest. So let me have your response. Which of the objects labeled A or B is at rest? Still expecting our response. Okay. The boy labeled as A is at rest. Why? Because no distance was covered. No distance was covered. And the boy labeled as B is in motion. Okay? Because he moved from point X to point Y. So there was a displacement, there was a distance covered. So this takes us to the topic of today, motion. Motion is something that happens in our day-to-day activities. Virtually everything we do in daily basis and capture motion. When you leave your house, you go to the school, you are one way or the other in motion. That is, you have to walk down to your school or probably board a vehicle down to your school, and that is motion. Even right in the room in our house, when you move from the parlor to the seat, from the parlor to the bedroom, is also motion, right? So motion happens on daily basis. It happens on daily basis. Even right in our schools, motion happen. Okay, so we are going to consider the proper definition of what motion is, and also we are going to explain the concept of motion. I believe we are all together. Okay, so I'm going to rub the board. Still working on the topic, motion, right? Okay, so I want to send a note, the definition of motion. Okay. So motion, here we have the definition. Okay, so we have the definition of motion on our screen. Definition of motion. Motion, by definition, is a change in the position of a body with time, with respect to a reference point. Motion is a change. So take note of the word change in position. Okay, it is a change in position. So if motion occur, there have to be a change in position. Okay, an orange falling from a tree, there's a change in position from the tree to the what? To the ground. So that is motion also, right? Are you leaving your house, walking down to the school, or boarding a vehicle down to the school? There's a change in position. Your initial position is your house, and then the final position is the school. So motion has to do with change in position of a body, right? With time, with time. It has to be with respect to time. Okay. So if I leave my house at a particular time, there, for me to change a position or change location from my house to the school, it will take me a certain period of time to get to the school. So time is involved in motion. And with reference, with respect to a reference point, to a reference point. For every motions, there's always a reference point. That is, the reference point is where you can, what you can call the initial position of the object before the displacement was done or before there was change in the position. So we have a tree and there's a mango on it. So the reference point of the mango is that tree. But when there's change in the position, it leaves the space, it leaves its position of being on the tree to the ground. So we can reference back that the initial position of the mango was on the tree, right? So motion is defined as the change in position of a body and objects with time. Time have to be involved with respect to a reference point. Okay, so I wrote here that motion exists in various forms and occurs in all the three states of matter. It occurs in solid, it occurs in liquid, it occurs also in gases. Okay, it occurs also in what? In gaseous substances. Okay, for these gaseous substances, let me use a practical example for us. While you are cooking at home and the pot that you use for the cooking process is closed, what do you discover when you open the pot? You see vapor moving from the pot to the atmosphere, and that is motion. Okay, so motion has happened in a gaseous form also like that. So the vapor escaped to the atmosphere, and that is motion. There's a change in the position from the pot to the atmosphere. All right. Okay, so in liquid also we have motion. We have motion, of course. If you have a flowing river, a river is not stagnant, so it moves from one point to another. And that's why we have wave. Okay, wave. When you visit the ocean, there's a wave that travels from one point to the other. So that is also motion. There's a change in the position of the wave from where it was to another what? Another point. So motion occurs in all the three states of matter. It occurs in solid, it occurs in liquid, and gases. So take note, you can be asked in UTME exam that which of the following, in which of the following can motion occur? And you'll be given options, and probably the last option could be all of the above. That is, all of these solid, liquids, and what? Gases. So the answer should be all of the above. That is, motion can occur in solid, it can occur in liquids, it can occur in gases. I believe you understand that, right? So that is the definition of motion. Take note, when you are defining motion, these key points have to be there. Change in position, very important, with time. These are the key points, the key word that have to be in your definition. And reference point also have to be in your definition. Okay, so if you are following me and you understood the definition of motion, as I've explained just now, please kindly signify so we can proceed. You understood the definition and the explanation I just gave about motion. I want you to give me a thumbs up in the chat box. I'm waiting. I want to be rest assured that we are following me. So if you are following me and you understood what motion is, please thumbs up in the chat box or say yes, I understand. Still waiting. Still waiting for a response. If you understood what motion is and the explanation, okay, good, okay, okay. All right. So I believe we can proceed. We can proceed. Okay. So I'm going to send a picture to us. Okay. All right. A picture to make it more easier. Okay, now we are going to consider the types of motion that we have, the types of motion. But before that, let's look at some example of motion in our environments that we can relate with. Example of motion that we can relate with. Okay, so I've sent a picture. All right, let's consider another picture. I think that will be more better. Okay, let's make use of this. All right, so we have some pictures here. A car moving, right? So this is an example of motion. A car moving from one point to another. A car moving from one point to another. An apple falling from a tree is also motion. Also, we have a ball. You know, when you give a shot to a ball, it also moves in the air. So this is another example of motion. Then we have a train moving also from one point to another. All these are example of what? Motion. All these are example of motion. So we can have so many examples of motion, even that are so close to us. I made mention of us leaving the house and move to the school. That going to the school every day is an example of motion. Okay. Also, even in our own personal house, when you move from one location of your room to the other one, is also motion, right? When an object falls from your hand while you are home, is also motion. So all these things are practical examples of what? Motion. They are all practical examples of what? Motion. I believe we are together. So we are going to consider the types of motion that we have. The types of motion that we have. Types of motion. Okay. Now I want to consider the types of motion. And we are going to use these examples I stated above here to, now we have, to be able to list out the type of motions we have, we are going to make use of this. We have the first example of motion says the movement of the earth around the sun. The movement of the earth around the sun. The movement of the earth around the sun. So this is an example of motion, and it also gives us one type of motion. You know, we have different type of motion. Okay, so we are going to be considering this example and relate it to the type of motion we have. The second example says the rotation of the earth about its axis. The rotation of the earth about its axis. Okay, we have another one that says an aeroplane flying in the sky. An aeroplane flying in the sky. So this is another example of motion. A boy walking or running. A boy walking or running. So starting from a boy walking or running. Of course, when you are running, you follow a particular path. So we can say a boy was running on a straight line, and that is linear. A boy running on a straight line, that is a straight line, right? And it's moving, the boy is moving from one point to the other while running. From one point to the other. So from this, we can say we have what we call translational motion. Translational motion. That is moving from one point to the other on a straight path. Moving from one point to the other on a straight path or a straight line. So it's called translational motion. And the diagram I sent earlier, if you check all those examples there, they represent translational motion. Okay, so let's look at that of the rotation of the earth about its axis. This, if you are to use a very close example, let's make use of the fan in our house. Okay, the fan in our house has an axis. Okay, let's say, oh, this is a fan, and we have the three blades, and there's a point here, and this keep moving in a round movement, but it does not leave its position from this point of what? Of axis. It keeps moving around the same movement round, but this point still remain intact. It's not because it's moving around, then it will move from that point of axis to another. No, it remains like that. So the point of axis is fixed, but the blade moves around the what? The fan, the same movement like that about the axis. And that axis is that fixed point in the fan. So this is the same with what we are saying about the rotation of the earth about its axis. And that gives us another type called rotational motion. Rotational what? Motion. Okay, that's rotational motion. We still have two more types that we're going to discuss, but I'm going to give us the definition of each of them. Then we are going to discuss it in details. I've mentioned two out of the four we have. I said we have translational motion and rotational motion. We also have oscillatory motion and random motion. Okay, so let's consider the definition of those four types of motion that I've mentioned earlier. Let's consider the definition, and we are going to explain that in details. I believe we are still on the same page. I believe we are still on the same page. If you are with me, please thumbs up. All right, okay, I have a response. So I believe I can rub off the board. We want to consider the type of motion. Types of motion. The types of motion. All right. So we want to consider the type of motion, one after the other. Okay. We have the second one. Type of motion. All right, so we have two more. Okay, so this is the third one. One more left, and we can explain the concept behind each of them. All right. So, and we have the last one now, the type of motion. All right, so we have the four type of motion. We have the four type of motion on our screen. The first type of motion is random motion. Random motion. Random motion is the movement of a body in a zigzag or disorderly manner. Disorderly manner with no specific direction, as shown in the diagram below. I'm going to send a diagram for us to see that what random motion is all about. Okay. We want to check a diagram that talks about random motion. All right. So let's look at this. We are going to look at the diagram, and both of us are going to agree that it has no direction. It has no specific direction. I'm coming. I want to send the diagram so we can all see what random motion is all about. All right. Random motion. Okay, so this is a diagram that explains what random motion is. On your screen, you have a butterfly. Now, this is a butterfly moving randomly, or let me say zigzag, in a zigzag direction. So we can't predict the direction of this butterfly. So this movement of the butterfly is said to be a random motion. It's said to be a random motion. Also, our cooking gas at home, the cylinder, inside the cylinder, we have gas. And the movement of those particles of gas is also in random way, is a random way. The gas move in an indirect direction, or they move in a non-specific direction. Are you getting me? So particles that move in a directions that are not specific, or that move through a direction that is probably not having a specific direction, whether straight or circular or spherical, are said to be particles that undergo random motion. And this butterfly explains better its movement in the space shows that it's moving in a direction we cannot predict. And that direction is not having a specific direction. Like a car moving from point A to B, that is specific. But for this illustration, the butterfly moves randomly. And this is why we say that a good example of a random motion is the movement of a butterfly in the space. Okay, so that is for random motion. Let's go back to our definition. So random motion, a body moves in a zigzag or disorderly manner. Please take note, in a zigzag or disorderly manner, and it has no specific direction. So we have example, we have dust particles in the air. Of course, dust particles in the air also undergo random motion. There's motion of smoke particles also undergo random motion. And also the motion of what? A butterfly. The motion of a butterfly. So this is what we call random motion. Random motion, it is a situation whereby a body moves in an indefinite direction, or let's say moves in a zigzag manner. So it's said to be a random motion. Now the second type is translational motion. This motion is performed by a body in a straight line from point P to another point Q, from point P to another point Q. Now, if you walk from one end of the classroom to the other, you have performed translational motion. We said earlier that our movements, even from the house to the school, is motion, right? So let's imagine that the route to your school is a straight line or is a straight road. You don't need to take some corners, just a straight way. So you are moving from a point of your house to your school. That is also a translational motion. So moving from a point to another point is what we call translational motion. And we can cite different examples under translational motion. We can cite different examples under translational motion. Okay, so let's take note that translational motion is also called rectilinear. It's also called rectilinear motion. It's also called rectilinear motion. Another example of translational motion is the dropping of a fruit from a tree to the ground. A fruit dropping to the ground is also translational motion. So let's look at other examples we can have. A boy moving from point A to point B, translational motion. A car moving from point A to point B, translational motion. Okay, and we also cited that a fruit falling from a tree is also translational motion. So we have so many translational motion that we can cite as an example. So translational motion talks about a body moving from one point to the other point, from one point to the other point. So 2 points are always involved, the initial point and the final point. The initial point and the final point. Okay, so we move on to the next one, which is rotational motion. When a body moves in a circular path, about an axis, it has performed what we call rotational motion. In other words, rotational motion is the motion of a body performed in circular paths about the axis. Rotational motion is the motion performed in a circular path about the axis. And I cited an example earlier of the motion that deals with the fan. The fans move in a circular path about a particular axis. So that motion is said to be rotational. Take note, for rotational motion, it has to be about the axis. About the axis. So also, if we have the planets, we have the planets, they revolve around the sun, the 9 planets revolve around the sun. That also is another example of rotational motion. Okay, so we have the rotation of a blade of a fan, all right? The rotation of a wheel about its axis. The rotation of a wheel about its axis is also what? Rotational motion. The rotation of the earth about its axis is also rotational motion. The motion of a moving vehicle wheel, all these are examples of what? Rotational motion. The vehicle, when you check the wheel of the vehicle, it also rotates about a particular axis, and that is called a rotational motion. Okay, so I believe you are following me. We'll move on to the next one, which is oscillatory motion. Oscillatory motion. Oscillatory motion. This is the motion of a body in a to and fro manner. Underline the key points. To and fro. About a fixed point. About a fixed point. A to and fro manner about a fixed point. Oscillatory has to do with to and fro, not circular. So we have to get the difference. Rotational is circular about the axis, but oscillatory is to and fro movement about a fixed point. In our SS1 syllabus, in practical aspect, we be discussing, probably some of us have come across what we call simple pendulum experiments, whereby you'll be given a rotor stand, all right, and you attach to it a pendulum bob, and you'll be asked to take the frequency of the oscillation of the pendulum. So you have to draw the pendulum to a particular angle, then release it. When you release it, what you notice is that the pendulum is moving from a point to another point, then returns again to that point and goes back to another point, comes back like that. It moves in to and fro movements. So that movement is called oscillatory motion. Oscillatory motion. The movement of a pendulum moving to and fro is said to be oscillating motion, oscillatory motion. Okay, let's write down the definition. When a body moves to and fro from a fixed point, we say the body is oscillating. Now, for this experiment I gave, what is the fixed point? The fixed point is this. Where you attach the thread of the pendulum bob is the fixed point. And the pendulum bob keep moving and the fixed point is still maintained. So for oscillatory motion to happen, we must have a fixed point. All these key points we are supposed to take note of them, because when you are defining, you have to put them in your definition. Or for the sake of CBT, UTME question, you can be asked question that has to do with all these key definitions. So there must be a fixed point in oscillatory motion, and the movement is always to and fro. It's always to and fro. So let's consider examples on that. We have example of oscillatory motion include the motion of a balance wheel of a wrist watch. A balance wheel of a wrist watch. If you notice, our watch has three particular indicators, the ones that indicate the seconds, the minutes, and the hours. If you are very conversant with those wall clock, you will see when the seconds is counting, it moves in one way that it seems like it's moving to and fro, tick, 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 tick. So that also represents an oscillatory motion. What about a boy on a swing? You know, when you go to an amusement park, you have a swing, right? Someone is sitting on the swing, and where he's sitting is attached to the top of that swing. So when you push the fellow, or when you push that particular person, you notice that the person is, okay, let's have an illustration. Okay, let's say this is the swing. This is where it's going to sit down. So it's attached to this fixed point, and someone is sitting on it, right? When you push this fellow, what you notice is that the person will start moving in this direction, going to the front and still coming back, to and fro, to and fro. And that results to oscillatory motion. It results to oscillatory motion. Another one is a loaded test tube. A loaded test tube inside water. A loaded test tube inside water will not sink inside the water, no. And it's not going to be on the surface. What you are going to observe that the test tube is going in and out of what? The water. In and out of what? The water. So a to and fro movement is what you are going to be observing in what? In that experiment. So these are the types of motion. These are the types of motion. And we can be asked questions pertaining them in UTME exam that which of the following illustration depicts random motion? And you'll be given some illustrations as options, and you have to pick the correct one that depicts random motion or probably that depicts rotational motion. Okay, so I believe you are with me. So if you understand the type of motion, I would like to have your reaction in the chat box. If you understand the type of motion, I want to have your response that yes, I understand type of motion. If you understand the types of motion, thumbs up in the chat box so that we can proceed. Okay, can I have one more? I'm waiting. Can I have one more? Waiting. Do you understand the types of motion? Waiting for a response so we can proceed. Yeah, I've gotten a feedback. I need one more. Do you understand the types of motion? If yes, kindly signify in the chat box. All right. I'm still waiting. If you understand it, okay. Thank you. Okay, let's proceed now. I will send us some pictures so we can have that. Okay. Okay, so now we want to discuss the cause of motion. The cause of motion. Now let's consider this diagram. Let's consider this diagram. Now we have an object here and an object here. Now the question I'm going to ask is that if nothing is applied to these two objects, are we going to observe any movement? Will there be any displacement? Or will there be anything that will happen to the object? I have an object here. Okay, this object can be like this for years and nothing will happen to it except an external force is applied to it. So what we are considering is the cause of motion. What really brings about motion? Something is responsible for motion. And that is what we want to discuss now. Something brings the scenario motion. What really happened that makes motion to exist? And I said it that if I have an object placed somewhere and nothing as an external force is applied to this object, the object will remain like that. it will be static. There will not be a change in the position of that object. But if peradventure I decide to push the object, I'm going to discover that the object is moving from its initial point towards the direction I'm pushing it to. Or if I decide to pull the object, I'm going to discover that the object is moving towards my own direction. So what happens is that pull and push brings the terminology or the phenomenon motion. So the cost of motion is pull and push. The cost of motion is pull and push. So when we pull an object, there will be a change in the position and time will be involved. And there will also be a reference point. Or when we push an object, there will also be a change in the position of the object. Time will be involved, and also there will be a reference point. Now, can we push and pull an object without something? Of course, something is involved also for these two to take place. Pull and push. You can't just pull and push an object without applying force. So the cause of motion is force. The cause of motion is force. So we apply force to pull an object or to push an object. And what we observe is that motion occurs. Motion what? Occurs. Is that again? Force is the cause of motion. So when force is applied to an object, a static object, then motion will what? Will occur. So it's either we apply the force by pulling or by pushing. Okay, so now this force is now subdivided into two. It's subdivided into contact force and also field force. Contact force and field force, which we are going to consider now, the two categories of force that we have. Now, this is contact force. Contact force. Now, what is contact force? Contact force is a phenomenon whereby an object moves or change a position when it's in contact with another object and force is applied. That is, there will be a contact between the two objects when applying force. If I'm pushing an object, I, as a person, is referred to an object. The object I'm also pushing is another object. So two objects are in contact by force. Okay, there's a force applied between those two objects and motion takes place. So contact force, there must always be, we are expected to always have two objects, and two objects will be in contact. The two objects have to be in contact before motion can occur. So that force applied is called the contact force. From the word contact. So two objects, two body, two particles have to be in contact physically for motion to occur. So we have example here, applied force. So this is someone playing a game here. You can see this is an object, this, and also the person holding the bat here is another object. So these two will be in contact for motion to what? To occur. They will both be in contact for motion to occur. And we have another one, tension force. We can see someone here, another person here. Both of them are in contact by a rope connecting them, and they are trying to pull the rope apart. So the force applied there is a contact force. They are both in contact. Okay, so we have another one, friction. Of course, let's take an example of a vehicle. A vehicle is moving on the road because of friction. So the road is an object. The vehicle on it also is another what? Object. So the tire of the motor of the vehicle is in contact with the ground or the road. And that is why friction is taking place. You know, friction has to be between two bodies, right? Friction is taking place and it makes the vehicle to move forward or probably backward, either of what the direction. So friction is also another example of contact force. We have applied force, we have tension force, and we have friction. All these are contact force. Now let's consider the non-contact force, which is also known as the field force. So that will be the opposite of contact force. Contact force, the two objects have to be in contact physically, but for non-contact, they don't need to be in contact physically. So let's check that also. Okay, now let's look at this. We have magnetic force under non-contact force. We have magnetic force. And what you observe here is that all these that you see here, they are pins and they are metals, of course. So what you can see is that the magnet is magnetizing those pins to itself. Of course, there will be a motion, but both objects were not in contact for motion to happen. As you can see, the pins were placed on the surface and the magnet was far a bit from it. But because of the magnetic force, the pins have to move to the direction of what? The magnet. So that is an example of non-contact force. We have gravitational force. An orange falling down from a tree to the ground is also a non-contact force because the ground and the tree are not touching each other physically, but there's a force that makes the orange to fall down to the ground. There's a force that pulls the orange to the ground, and that force is called gravitational force. The same thing is applicable here. We have electrostatic force. So when we have a situation whereby motion occur, but when force is applied, there's no physical contact between the two objects or between the two bodies, then we say we have a non-contact force or field force. We also call it field force. Non-contact force or field force. So these are the two types of force that we have. Okay, these are the two types of force that we have. Please take notes that we have force for motion to occur. Force have to be involved, either through pull or push. And we said that we have two categories of force, the contact force and the non-contact force. We are going to continue this topic in our next physics class. And for today, we are going to stop here. And I want to have a recap of what we've done so far today. We've discussed about the concept of motion. We discussed about the types of motion, and we considered also the examples of motion. Then we considered what is the causes of motion. And we said the causes of motion is through pull or push, which needs force. That is, force is the cause of motion. And we went ahead to subdivide force into two categories, that we have contact force and we have non-contact force. We said contact force have to be physically in contact for motion to happen, and non-contact force non-contact force is not necessarily, they are not supposed to be in physical contact. Okay, non-contact force, physically, they don't need to be in contact, but motion will take place. So for the next class, we are going to continue with the topic motion. I will urge us to ensure that we do not miss any parts of this live section. And also, do not forget that your app is always there for you. A1 Tutor app. Do well to visit the A1 Tutor app to practice questions concerning the topic you have been doing so far for UTME, WAEC, NECO, and all other form of exams that we have there. Do well also to watch our detailed video on the topic motion, or you check SS1 as a class. You are going to have the topic motion. Yes, you can take your time, watch it, and have a wide knowledge on motion. You can even watch ahead of the next class so that when we continue from where we stop, we can follow the class. Okay, do not forget that tomorrow is another day and we are still meeting by 12 noon. We have our live class again. Try your best not to miss any of this class. Thank you for your time. See you tomorrow. Thank you.